All right, let's talk about one important consideration. We've already defined the difference between our absolute and relative extrema, right? And remember, we could also rewrite these. Our absolute we'll call global, right? These are the overall maxims and maximins, and our relative are local max and mins, right? So on this little tiny neighborhood, C is greater than everything around it, so it's a local maximum, but the overall largest value that this entire curve takes happens at A. That's our absolute or global maximum. Okay, one important distinction, because this happened a lot last semester on this particular quiz. I had a quiz where I asked students to find these global max and mins. And a lot of students relied heavily on that first derivative test. But the first derivative test doesn't tell us everything, right? Imagine in this problem, the first derivative would be negative because we're decreasing, positive because we're increasing, and then negative again as we decrease again. And it would, just by luck, correctly tell you that B was a minimum, right? It would tell you it's a relative minimum, and you, if you use this on accident looking for the absolute minimum, would be correct, but not necessarily for the right reason, right? If this function kept going, whoop, and ended here, and there was some new point D, that would have been the absolute minimum. And so we have a whole nother test coming called the extreme value theorem. Really, it's a theorem that we'll then use to do a test. But because of that, we cannot just use our first derivative test. We have a whole different test that includes actually finding the values of our functions at every candidate, including the endpoints. There are going to be, of course, exceptions where you might be able to decide, right? If we were dealing with a parabola, for instance, and we knew we were decreasing then increasing, and there wasn't another decrease, we could probably pretty realistically say that that vertex was a minimum because there's nowhere else we could have ended up down. So it requires us to almost do a little bit more talking about what's happening with our first derivatives if we're trying to just use them as opposed to this extreme value test based on the extreme value theorem we're going to get in just a second.